Hi, your next challenge is find the smallest number in an array. You are to create a function that takes an array of numbers and returns the smallest number in the set. Now, I know what you're probably thinking. We just did essentially the same thing for the maximum number in an array. And there's a part of me that sympathizes and finds this unimaginative on the part of the website to essentially have you do the same thing, but in reality, you need to be doing these things multiple times, many more than just 2 times. So we are going to go through this and solve it again. Or maybe it's even been a while since you watched the last video and you don't even remember what you did to solve that one. So it's good exercise in that sense, and really one of the highlights of this channel is repetition. So we're going to repeat a lot because that's how stuff sticks in your head and becomes second nature to you. So if you already know it and it's easy, then you should be able to knock it out fast, right? Let's look at it that way. Again, I think the problem's very clear. Use the examples to make sure you understand 2 is the smallest value. Notice we've got some negatives mixed in. They threw in some numbers that aren't integers. We got some decimal components there, so that's showing that we're going to be dealing with a little bit different input. We'll go to the coding section, pause the video, think about it. Hopefully you can crank this one right out, and then I'll go into it. And as I alluded to, notice that the input's coming in as a double array, square brackets. Make it an array. If they weren't there, it would just be a single double value. And we're returning a double. If we haven't talked about a double yet, that allows you to have the decimal part to numbers. You don't have to deal with whole integers anymore. The double is short for double precision floating point. If you want to search that phrase, you can learn quite a bit about how those are implemented, the amount of precision they have, that sort of thing, which is good to know. They cover most use cases that we'll use, but it's good to know that there are limitations there. There's also a single precision type that is just referred to as a float, but double refers to double precision. It probably sounds weird calling it a double at this point if you're not familiar with single and double precision floating points, numbers, but that's a quick rundown of why it's that way. Anyway, so we're dealing with potentially values with decimal parts too. They're not whole integer values. So similarly, we'll do it the long way first. And if you remember, I gave us a variable to store the minimum value as we sort of iterate over this collection of values. At all times, we're going to maintain the minimum value encountered so far and update it when it's appropriate to. Oop, and look at my habit even wrote out int. We're not dealing with ints. So double min value, I'll call it since we're finding the smallest number. Min value equals. And remember last time how we used the int32 class for integers to sort of just start with the maximum value? Or in that case, the minimum value, because we were looking for the largest number. So since we're going the other way, we're going to do the opposite here. Sure enough, there's a double class. They have a max value field that we can reference that'll give us the highest possible double value that you could encounter. So let's start with that. Then anything we run into should, likely the first double in our collection is going to beat that value in terms of finding the lowest, and then it will be updated. So we'll start with the max value. Okay. And then remember we had to go over the collection. We did this last time by using a for loop, and I'm going to do something very similar, but I thought it might be a nice time to introduce the for each loop, which is a simplified version of the for loop where you don't have to deal with indices, index values. It's when you don't really care about what the index value is. In this case, we don't. We just want to make sure we go through all the values. It doesn't really matter which order we do it in. So we'll go for each is the new keyword for that. And then you specify the type in the collection. Double, that's the type of in the array, they're all doubles. And then you just give it a variable name, like how we made something up for min value. I'm just going to call it D for short. And the in keyword followed by your collection. And notice that this type has to match the type of your collection. And it does, so we're good there. Put our curly braces there to define the scope. Everything within the curly braces will be executed for each time going through the loop. And now we're going to get that value. We can say if D, we have a reference to it right here, D. If D is less than min value, we know we set a new low value, so let's update our state there to capture that. The new minimum value is D, and if a new minimum value isn't encountered, we essentially skip this part, this true evaluation, and we just carry on to the next double in the collection. So then we know once that process is done, we can simply return the minimum value. Remember, after this closing brace here, the loop is done. We've gone through every value and updated, made sure we captured the minimum at every point. So we'll check this. Hopefully we get some good news. Oh, I think I see one problem. Yeah, the name double does not exist. Remember, double's not something we made. We've got to bring that in. We took it from the Microsoft Docs, and you'll notice they specify that the namespace is system. So let's add a using system. Using system. Okay. Now we should have a definition for that double class, an implementation of it, and there we go, we're happy. Good. That was more work than we had to do, but it's nice for you to see how this could be done in practice. And the shorthand we're going to use in place of this now is likely doing something very similar to this under the hood. If you remember, we used LINQ last time, LINQ, the language integrated query, to use this really nice max function that just grabbed our collection and did this all for us. We had a nice one-liner. This would be a good time to pause the video and do that part yourself. You can feel free to look up, go through the Microsoft Docs and find what you need to do that. I'm going to refresh at this time to clear the code. And then I will write this out in one line. My internet's really chugging along today. There we go. Okay, so I'm going to bring in that using system link, I believe is what it's called. And then we can make this as simple as array min, I believe. So let's see what we get for that. And look at that, isn't that great? One line of code, very readable, tells you everything you need to know. You don't have to see all that looping and variable updating. And yeah, that's nice and sweet. This is the way I would do it. So if you remember last time too, we just showed another way you could do it, where you sorted the values in the array and then you took the last value to get the max. We could do the same thing here, return the first variable this time to get the lowest value, since the sort does ascending order. I'm not going to do that here. We talked about how sorting is performing a lot of extra work that doesn't need to be done to solve this problem, but you would end up with a correct result, and oftentimes the implementations that we do are not the most efficient thing. So we try to be most efficient, but honestly, a lot of us aren't perfect. We're not, you know, really hardcore computer scientist professors, and we do our best. When we find the inefficiencies, we improve them. And yeah, that's how we do it. So hopefully this was helpful. I hope you just crushed this one since we had that find maximum value video recently. But if not, hey, keep your head up, keep chugging. That's how it goes. You know, this is hard for everybody when you start. So hit me up with questions and comments. Thanks for watching.